that not a word?
You should stick to real words.
Does dynamic?
No.
4:30 work. 4:30 is another time.
Yep. Oh, yeah. Alright, so since I already set it up, I'm just going to show you how to hold it. I'll let you do it since it's the first time. It's on right now, so don't talk too much. But
Your wife is watching.
you can say hi. She can hear.
Hi, Julia. That's like Myra and her hubby would always be
All the
watching.
time, yeah.
She's always
It's
like,
pretty
hi,
funny.
guys.
Yeah. You can shut the door too. It's already on. Just pick it up.
I'm doing it.
Yeah, just try that one. Just show you how to do that.
All right, guys. Thank you again for tuning in for another round of Weather School again every Wednesday at 1 o'clock. And we were going to talk about tornadoes last week. That was my plan to begin with. However, really even more poignant after what happened over the last few days. The tornadoes touching down for us Monday morning, really across a lot of the southeast and the middle of the country. Let me see here, for some reason this is not clicking. But it has been, there we go. But really want to kind of focus on a bunch of different things when it comes to tornadoes, how they form, why they form, the different scale, the intensity, and then toward the end here we are going to try and make our own, hopefully with some things that you already have around the house. Of course you can buy a little thing that makes this really easy, but we're going to make our own with a balloon, some duct tape, and we've got the scissors and some stuff you can put in there to make it a little bit more interesting as well. So I want to start off with tornadoes. They are extremely powerful, and there are some that are weaker, but still the weak ones can do a lot of damage. But this is the one that happened earlier this week. We are looking here, EF3 tornado damage that moved through part of Orangeburg County. There's also EF3 tornado in Aiken County, Barnwell County. So if you're South Carolina, you're familiar with these areas, and of course familiar with these storms that moved through on Monday. This one, Samantha McCollum, who's behind the camera, was down there and took this picture. And I mean, Samantha, you can describe what you saw down there. Pretty devastating.
Yeah, it was awful. I mean, there was no walls left. All the fiberglass that made up those walls was scattered into the trees all over the place. I mean, when I went around the back, you could tell where the kitchen was because all the seasoning and everything was all just scattered out.
It's just everything
Yeah.
into the yard. There's a car back here somewhere that's covered in everything too. So really scary, and it's something that you have to kind of plan for. You've got to be ready for when this type of weather might be coming your way. So when we talk about a tornado, what we're looking at here, and I don't know if that's too small, Sam, but
No,
the official definition is a violently rotating column of air touching the ground and then also attached to the cloud. So usually that's the base of a thunderstorm cloud. So that's the clinical definition, if you will, but essentially we've got that column of air extending all the way from the cloud to the ground. So when it's officially a tornado, that means it is in contact with the ground. So what we need here, three of the big ingredients for a tornado to form, is going to be instability in the atmosphere, wind shear in the atmosphere, and typically a lot of moisture as well. If you were up early at all on Monday morning before those storms moved through, you could just feel it. It felt a little different. There was a ton of humidity in the air, all that extra moisture. The winds were already kind of going crazy down here at the surface, at the ground, but also up higher in the atmosphere. So they really have to come together just right, but these are some of the ingredients ingredients that meteorologists use to forecast that tornadoes might be in the forecast. A severe thunderstorm will produce a tornado, while another ingredients. So what we do is try and forecast when everything's coming together so that we might see that severe weather. When we talk about instability in the atmosphere, you can kind of think of it as if you're, let's say, in the pool and you've got a basketball. You try and push the basketball down to the bottom of the pool, try and get it under the water. What's it want to do? It wants to shoot right back up to the top. And that is basically the same idea here when we talk about instability. The air at the bottom of the atmosphere, down here closer to us, wants to get up to the top. And because of that, and as it's on the way up, that's part of what creates our stormy weather and ultimately can lead to some of those severe thunderstorms. Along with that, it can lead to tornadoes. So when we talk about wind shear, the biggest reason for that is that it allows thunderstorms to organize. All that means is the wind is essentially the same all throughout the atmosphere. So what happens when a thunderstorm develops, it pops up, it keeps growing up, but eventually it just kind of rains itself out, collapses right back on itself. When we have wind shear, kind of the opposite here, we have winds going different directions and different speeds as we go throughout the atmosphere. That tilts our thunderstorms. And what that means is that the downdraft and the updraft are in two different places. So this thunderstorm is able to survive a lot longer. It holds together, and then because it's more organized, we can end up with much more serious weather out of it, whether that's severe straight line winds or tornadoes can form out of those as well. So how a tornado forms. This is kind of looking at it when we look at that wind shear. We were talking about instability. We've got surface winds going one speed in one direction, but then up higher in the atmosphere, they're moving much faster. This is pretty much the definition of wind shear. So what that does for us, and I can show you here with this bottle as well, we've got winds going slower at the surface and then much faster at the top. It creates this roll in the atmosphere. We know tornadoes don't spin like this. They spin vertically, right? But this is where it starts. We get kind of this rolling in the atmosphere. And then we were talking about instability. That air wants to shoot up. We get these updrafts. We have this unstable air. And now all of a sudden, instead of our atmosphere spinning like this, it starts to spin a little bit more vertically. And that's where we get this rotating air. And ultimately, we end up with a rotating thunderstorm. So that is what we call a supercell. It's a thunderstorm that's spinning. And once our thunderstorm is spinning, that gives us the chance for maybe a tornado to come out of it. So we've got a lot of moisture in here. We have our instability. We have our wind shear. And if we are going to get a tornado, one of the first things you might see is this lowering of what we call a wall cloud. And that is going to be kind of a sign that, hey, this storm might produce a tornado. So we get kind of a larger cloud that starts to come down, generally, and not as big as the entire storm, but just kind of something that you can look for. Yeah.
So there has been a question that says sometimes you can't all that.
Absolutely. Sometimes you can't see them because they are wrapped in rain. We call those rain-wrapped tornadoes. And if you can't see it, it's still going to be a tornado, but I think maybe the term you're looking for there is rain-wrapped. But that's part of the reason when a tornado warning is issued, you can't look out the window and look to see if you see a tornado because there's a good chance you just wouldn't, especially at nighttime. Then you're basically, the only way you're going to see it is if there's a lightning flash or a power flash from one of the transformers. So you've got the severe thunderstorm, the supercell that's spinning, the wall cloud, and then out of that sometimes we end up with this rotating column of air that makes its way down to the ground. If it doesn't get all the way to the ground before it gets there, we call that a funnel cloud. A lot of times we'll see reports of funnel clouds that, thank goodness, don't make it all the way down, but if it does, get down to the ground, then we have a tornado. But again, one of the things that's so interesting about these and why scientists continue to study them is a lot of times we don't know exactly why one supercell storm will create a wall cloud and then ultimately a tornado and why one supercell storm won't. So when we talk about supercells, all that really means is that it's a thunderstorm that's rotating. So what sort of things in the weather give us this setup? One of the big things, you hear people talk about this with tornadoes, is often we end up with two different air masses colliding. Usually it's a warm, moist air mass and then a much colder air mass. And that's exactly what happened on Monday. Warm front lifted to the north, so we had all of this warm, muggy, humid air down here. And meanwhile, cold front, colder air is trying to mix in. That can create that wind shear for us. And the other thing we're talking about, instability and moisture, that's all right down here in this area. When a warm front lifts to the north, what that means is that warm and humid air is pushing into the area. And this here, our cold and take over. So when we end up with a storm system with this sort of setup, we might see those ingredients that could bring severe thunderstorms and tornadoes. And I do want to stress here that really anywhere in our country, we have the chance for tornadoes. That is not going to be just tornadoes here, but every state in the United States has reported tornadoes before. Now, different times of the year, you might find them more prevalent in different areas, but it's important to know that this could be for anybody. So we're talking also about wind shear creating that. So we have another map here kind of taking it into South Carolina and the mid-Atlantic. We end up with winds going one direction at one speed, generally slower down here at the surface, and then the winds up higher in the atmosphere are moving much faster, and typically they have a little bit more of this direction to them, and that's where we get the wind shear and we end up with that spin. So you need this in the atmosphere to end up with a rotating thunderstorm. So that wind shear keeps those storms organized and longer lived. We know from our tornado, at least one of them from Monday, that we did end up with 31-mile track. So they can be on the ground for just a couple minutes, or they can be on the ground for a long time like that one was. The other way we can end up with severe thunderstorms and tornadoes is simply just from summertime, daytime heating. We talked about this when we talked about cloud formation, but the sunshine comes up, heats all of the air down here, and the same way a hot air balloon gets hot and wants to float up into the sky, that same thing happens with our air down here at the surface. So we can end up with what starts off as a really pretty day. We get hot air down here at the ground. It starts to go up higher and higher into the atmosphere. And if we have that instability, and if we have some wind shear, all of a sudden this can turn into a really powerful thunderstorm. That's a more typical setup for us during the summertime, where you get these pop-up strong storms. Our setup that we had on Monday, that's more typical of what we see in the springtime, when we have those colliding air masses. So a couple different ways that you can kind of get all of those pieces coming together. Let's talk about our Fujita scale. Now we call it the enhanced Fujita scale. So when you hear us say an EF0, an EF3, EF4, that's the power of the storm. So EF0, you're looking at damage here that's going to be right around, miles per hour, 65 to 85 miles per hour. Then as we work our way here to an EF2, then we've got winds that are up to 86 to 110. I included little pictures here to give you an idea of the type of damage. So an EF1, even though it's on the lower end of the scale, can still do considerable damage to roofs, can knock over and snap a lot of trees, and you have a lot of debris flying around. So again, we go 0, 1, but these are still really powerful storms. Go up to an EF2, we've got winds of 111 miles an hour to 135, and the same sort of deal here. The second story of that house, really very damaged. But you notice at this point, the first floor of that brick home, too, it is a brick house, is still relatively intact, still looks pretty good. So if you were under tornado warning and you did what you're supposed to, got to the lowest level of your home, got to an interior room, looks like this house, you would have been safe in there. So that's why we tell people to do exactly that. Now, if you were up in one of these bedrooms up here, you could have really been hurt. So that's why, again, when there's a tornado warning, you get to the lowest level of your home and away from windows. Now we're talking about an EF3. So this is getting up, and this is actually the category, or rather the strength of the storm that moved through our area. I believe there were 3 different EF3 tornadoes in our region. And you see here that damage even more so, and now it's starting to get down to the first and second floor. So this kind of storm is going to be extremely powerful and can create a lot of damage, and we've seen some of that. Now still, this is a stronger built house, so a lot of it is intact, but like the picture Samantha took and we looked at the beginning of this, that was an EF3 tornado, winds around 140 miles per hour, but because of the type of home it was, it really didn't stand a chance against that. So that's another really important reminder. A mobile home is not a safe place to be during a tornado. You need a plan ahead of time. Yeah.
We do have a question. How do you differentiate just heavy wind versus a tornado? So
yeah, no, that's a great question, and that's something that we saw this on Monday as well. So when we talk about heavy wind or maybe wind in a severe thunderstorm, that is going to be wind that goes in a straight line. It basically comes out of the cloud, runs into the ground, and then since it doesn't have anywhere to go once it hits the ground, it pushes outward. And it's generally all going in one direction. So when survey teams from the National Weather Service go out and look at the damage, they try and find out, is there kind of a rotation here to this damage, or is it all going in one direction? And sometimes you can even see it. Every tree has fallen in the same direction. And that's a good sign that it's going to be a straight line wind from a severe thunderstorm. But then if you've got some trees that are bent this way, some that are going this way, that's a better sign that maybe a tornado moved through. And Sam actually mentioned it, kind of one of the telltale signs when a tornado hits a house is that you see that insulation kind of flung all over the place in just about every direction. And that's one of the things that the survey teams did see.
Yeah, and when I drove out there, there was a good line of just downed power lines all going the same way. So
Right.
that would be more so.
So maybe that would
The
some
winds.
straight line winds there. So, and it depends too how big your tornado is. Some tornadoes are not very wide, maybe just 50 yards, and some other tornadoes can be a mile or even 2.5 miles wide. The longest one on record is 2.6 miles wide. Now, of course, that's not the norm. Most tornadoes are much weaker and much shorter lived, but these really powerful ones can be on the ground for a long time. Let's keep going here. This is when the pictures start to get really scary. We've got an EF4, so now we're looking at wind speeds that are 166 to 200 miles per hour. And you can get the sense here. Trees are just completely ripped. All their leaves are off. A lot of them fall down completely, and a lot of homes are just completely destroyed as well. So this is the type of damage where, again, you really need to be in a safe place if a storm like that comes through. Ideally, the basement or a storm shelter, but at the very least, the lowest level of a solidly constructed home. Definitely a mobile home, not a safe place to be during an EF4 tornado. And then as we get into the EF5, this sort of damage is just catastrophic, and the damage path is usually much, much wider. And you can see here, that, again, these are scary pictures, and thank goodness this is not normal. We do not see many EF5 tornadoes, but wind gusts over 200 miles per hour, and you can see just can completely ruin everything in its path. So when we talk about tornadoes, we talk about tornado safety, this is the sort of reason why. Now, it doesn't have to be this strong to cause damage and to hurt people, but it is certainly something that Mother Nature is capable of, and part of the reason, again, that we do take them so seriously. So this is a good time to kind of go over again really quickly watch versus warning. Watch, tornado watch, a severe thunderstorm watch. Those are going to mean that conditions are favorable for that type of severe weather. So you want to have a plan ready to go. Know where your safe place is in your house, and make sure you have some emergency preparedness stuff ready to go. Know where the flashlight is, that sort of thing. Charge up your mobile devices. But then a warning, that means that it is happening right now. That, or it's extremely likely to happen soon. And that's when you get to your safe place and you take action immediately. So on Monday morning, we were talking about tornado warnings here and there and another one there. Those people ideally are getting into that safe place in their home as soon as you hear that going on. So it's important to know when we have warnings, what county you're in, where you live in relation to your area, where your TV station is talking about, but also just to know exactly what to do if one of those warnings does come down. Talk about here the safest places to be, of course, inside your home. If you don't have a basement, that's okay, but what we want to do is get to the lowest floor, a center part of your house, away from the windows. The reason for that is any tornado is going to pick up all sorts of debris, and it could throw it at the windows, break the windows, and then we have glass flying around as well. So the more walls between you and the outside, that's what we want to do. So maybe it's a bathroom for you. That's here what's highlighted in this one, the bathroom inside the bedroom. So we've got 2 extra walls from the outside and no windows. And then if you do have one of these warnings in your area, it's a good idea too to have things in there with you that you can cover your head with to stay safe. Because let's say maybe if the roof was torn off of this house, if you were under blankets and pillows and things like that, you'd keep your body safer from everything that's outside.
They said even a mattress.
Yep, even a mattress is a great one. So again, that's why we have the watches that go into effect, so that you know some of this stuff might be going on and that you should be ready for it. Just want to see here what comes next. This might have been my last graphic.
And then remember I told you about the sneakers, that's a good thing.
Yeah, to know where your shoes are, exactly, have them ready to go and have them in your safe space. If that storm does come through your area, you're going to be walking out to a lot of damage and sharp objects, broken glass, could be nails and pieces of wood, that sort of thing. So that's another great piece of advice. So my goal is not to scare anybody when it comes to tornadoes, but it's just to make sure people think about it and that you're prepared. They can be extremely dangerous and cause incredible damage, but most of the time that is not the case. I've been doing this now for a long time, never actually seen a tornado myself, never had one come through where I live, but that doesn't mean that I'm not prepared for it, that I'm not ready just in case. So that's what I want everybody to kind of take away from this one. They do happen during the springtime is our most frequent time, and at least in South Carolina, and then also during the summer, some of those pop-up storms can turn tornadic as well. So the good news here is that the science is good, that we know the ingredients that might come together to produce them. So it gives everybody a little bit of a heads up, and then those warnings are getting better and better too. National Weather Service does a great job of getting those warnings out quickly to hopefully give people enough time to get to that safe space. So I think I was hoping I had a couple more pictures for you guys here, but I might have to pull those up at the end.
We do have a question from Gracie. Tornadoes on water versus on land.
Yeah, and I'm so sorry. I put the pictures into the computer and did not get them in here, but yes, a tornado over the water is what we call a water spout. It is still a tornado. If the water spout were to come onto land, then it gets renamed into a tornado. So a lot of times water spouts though can actually pop up on relatively nice days. Typically, if you're familiar with the Florida Keys or off the coast of Florida, that's where we see them most often. And that can just be from a warm, sunny day, all that rising air just gets a little bit of a spin.
I have a video saved on Facebook I can post in the comments if you guys wanted to see. It starts off as a water spout, but then once it gets on land, it is then a tornado, and you watch it come through the Gulf.
And do a lot of damage too. So they're weaker than our thunderstorm related tornadoes, but they can still be powerful. And if a thunderstorm does produce the water spout, then you can really have some powerful ones as well. But a lot of times they can be just kind of mesmerizing to watch because they usually are a little bit weaker, and a lot of times they do just stay out over the water and just kind of dance around. So yeah, Sam, I would definitely love to see that video. So that's a great question. So, and we are going to make a little bit more, I would say, similar to a water spout here. And a lot of you have probably seen this sort of thing before, but we're just going to try and make a tornado here in our 2-liter bottles. So what I would recommend, 2 2-liter bottles, take off the little things that are usually down here under the cap. Take those off, get them out of your way. And I'd fill this up about, let's see here if I can not spill water in our studio, but I'd fill this up about halfway to 2/3. So 2 2-liter bottles. The other thing you're going to need, let me see if I can pour a little faster. Other thing you're going to want are balloons. So that might be the toughest one to come by just at your house here, kind of on a random day. But what that does is allow us to just get a slightly better seal here on our tornado. Let's go just right about there. We'll go make this one a little bit smaller. Then what you're going to do is take your balloon, and ideally it's one that's a little bit bigger, and I want you to just kind of cut it off right at the neck. And what that is going to be for us is this is going to be our seal from one bottle to the next. What I want to do though, to make it a little bit more exciting, we're going to put in some food coloring, and we'll put in a couple things to float around. So now this is probably a project best done outside. Try not to spill any water, but let's just we'll go 2 drops, give us a little something in there. And then if you have maybe glitter would probably be the best thing. I could not find any glitter this morning, so I just grabbed seasoning. Just something to put in there so you can kind of watch it floating around, flying around. Now this is definitely going to spill, but we'll clean up afterward.
It's like the dirt.
Exactly, it's like the debris that flies around in a tornado. So, and now it smells nice in here too. This is just Italian seasoning. That way we end up with a few different types of seasoning floating around in there. So what I'm going to do, and I'd put in more water than this. I just did that for the sake of time. Probably go up to at least halfway, at least a little bit more than that. So then take your balloon, probably easier to do the end that has the part that you would blow on first. And you're going to put that over a good portion of your bottle there. And then try and get the rest of it to be right over top of it. Now this here is the trickiest part. It's definitely easier to do this with 2 people.
Do you need help?
I should be able to. Actually, yeah, that'd be great. If Brett can grab that. There you go.
And Julia says that you moved the glitter to the bonus room.
So, well here, actually, I'll do that part and then you can just stack it perfectly on top. So this is why it's better to have 2 people. You can just kind of hold that wide open if you go right in the very middle, and then I'm just gonna try and stretch that up and over. So there we go.
It smells good.
Yeah, it smells like Italian food. So now, unfortunately, this will not be enough to hold it. So the last thing that you really do need is going to be some duct tape. That'll just really sure it up. And again, this is not a perfect seal, so eventually it is going to leak. But it's kind of something fun that you can do, and hopefully you have a lot of this stuff around the house. If you do not have the balloon, you might be able to get away with Scotch tape or masking tape, something that's just going to create a little bit better of a seal than duct tape would. And the duct tape, I like that because it just kind of reinforces everything nicely. So I go around a few times here, and then I'm going to actually go up and down a little bit too, just to get us an even better seal. This Gorilla Tape is a little more intense than I was expecting. Here, if you can actually, yeah, Sam, you can cut that. Yeah, and I'll just do that one on the bottom. Mine is not going to be as pretty as hopefully yours will be at home, but then we'll kind of do the same thing just to reinforce this a little bit, and hopefully it will be here if I stage straight enough. And then all you're going to do is kind of flip it over. You have to give it a little bit of help, but then you'll end up with that tornado in there. And of course, this isn't exactly how it works in the atmosphere, but it is still a pretty good representation of at least the way they look. And again, I would do more water in there so it looks a little bit cooler when you do it. And don't put too much food coloring in, or then you won't be able to see your things flying around in there.
There's the tornado.
Well, you see the tornado, and you can see the debris flying around. And one of the things that we saw with our tornadoes earlier this week is what we call a debris ball on radar. And that is where radar is actually seeing all the different things flying around, whether it's insulation like Samantha saw, parts of homes, parts of trees, dirt, dust, rocks, everything. And the radar actually sees that flying around and realizes
Chairs.
that it's not rain. Yeah, chairs, furniture. And that's kind of what we're trying to recreate in here with our seasonings. So again, this is not, it's not a perfect seal. It's not going to last forever, but it kind of gives you something that you can do at home and just a neat way to kind of see this. You can also buy these little things that allow you to just screw them all together, and that will hold a lot better, give you a little bit stronger there, but still just kind of something neat to do when you're talking about your safe place in your house, where the family is going to go if there is a tornado warning, and just ways to make sure you're prepared.
Yep. When you guys go back to school, you could always make one of these so that you could show your classmates too. I think that they would think that was really cool.
I can remember my next door neighbors had one of these when we were growing up, and they had like the fancy thing that connected the two pieces, and I just thought it was such a cool toy. So a neat thing you can make at home pretty easily. Again, if the weather's nice enough, probably want to do it outside. That way you're a little less likely to get water everywhere. But ours is still holding together, so I'm confident you could probably pull it off. If anybody has any questions, we're going to look back through the comments section, see what you guys are asking. And again, just not trying to scare anybody. The chances that you're going to have a tornado ever hit your house are extremely, extremely small. But the chances there for just about everybody. So we just want to make sure that you're prepared and that you know what you would do if a warning was issued.
Yeah, and if you haven't had the conversation with your family where your safe place is or what your plan is for your home, it's a good thing to ask your parents.
Yeah.
Because.
So on that note, hopefully you can get out there and enjoy that. Maybe at the next trip to get the essentials from the grocery store, just grab a couple 2 liters if you don't have any at home. And then good luck. And if you do make your own tornado at home, please share a picture with us. Love to put them on TV and share your hard work.
I want to see a purple one. So.
I could have put that in. But thanks again for watching, guys. I think next week we are going to talk about kind of along the similar lines, but I just want to talk about wind, and we're going to try and make our own anemometers. So that should be a fun little experiment for you. I'll post on Facebook the different things you're going to need for it. If you want to make it along with us, you should be able to have some fun with that. So cool. Thank you guys so much for watching. See you next week at 1.